Welcome to The Explainer. Today, we're diving into this incredible idea from the work of Brian Cox. Basically, how can the exact same set of rules create something as tiny and perfect as a snowflake, and also something as huge and massive as a star? It sounds kind of crazy, right? But that's what we're going to unpack. You know, when astronauts go up there and look down, something really profound happens. They see our planet without borders, just one single interconnected system. But here's the cool part. You don't actually need a spaceship to get that perspective. The laws of physics, well, they can give you that same aha moment, that same crystal clear view of how everything is connected. So that's the big question we're tackling. How can these universal laws of nature be responsible for something so fragile and intricate like a snowflake, and at the same time for the mind-boggling scale of a star? It feels like two totally different worlds. But to get the answer, we've got to start really, really small. Okay, so our journey into this universal rule book starts with something you've definitely seen before, but maybe haven't thought about in this way. We're talking about the snowflake. I mean, people have been obsessed with this question for centuries. You've got the famous astronomer Johannes Kepler way back in 1610 just walking across a bridge. A single snowflake lands on his coat, and he just stops and wonders, why? Why does it always have 6 corners? Then fast forward to 1885, a guy nicknamed Snowflake Bentley, seriously, he takes the first ever photo of one, and suddenly the whole world can see just how ridiculously intricate and unique each one is. For the longest time, it just seemed like some kind of magic. So what's the secret? Well, it turns out there's no master plan, no grand blueprint for the entire crystal. The whole secret for that perfect 6-sided shape comes down to the shape of one single tiny water molecule. Yeah, just one. See, because of quantum mechanics, its 2 hydrogen atoms are stuck at this very specific 104.5-degree angle, and that angle forces it to link up with other water molecules in a hexagonal pattern. That's it. That one simple local rule, just repeated over and over billions of times, builds this incredible, complex beauty from the bottom up. And this is where it gets really mind-blowing. Because this idea that simple, local rules can create massive, complex things, it doesn't just apply to snowflakes. It scales all the way up. It literally shapes our entire universe. Okay, so when we talk about what determines the shape of, well, anything, there are really 2 big bosses in the universe. Down at the microscopic level with atoms and molecules, electromagnetism is the one calling the shots. But when you get to the really, really big stuff, like planets and stars, there's another force that takes over completely: gravity. So let's stick with the small scale for a second. Electromagnetism acts like an architect. It's the glue that holds atoms together, and it's super picky about the angles. It's what creates that precise, delicate geometry you see in a snowflake. It's all about how one molecule talks to its immediate neighbors. It's a local thing. But once you start piling up enough stuff, a lot of stuff, gravity just completely overwhelms everything else. It's this relentless, unstoppable force that pulls every single particle inward, toward a common center. It doesn't care about fancy angles, it just pulls and pulls, smoothing out all the lumps and bumps until you're left with the most simple, most efficient shape there is, a sphere. And that, right there, is why planets are round. So what you have is this constant cosmic tug of war between these 2 forces, and you can see it perfectly in mountains. A mountain's height is basically a standoff. You've got the electromagnetic strength of the rock itself pushing up, and you've got the planet's gravity trying to crush it back down. On Earth, our gravity is pretty strong, so it puts a cap on things. Mount Everest can only get to about 9 kilometers high. But then you look at Mars. It's got way less gravity, only about 40% of ours. And because of that, Olympus Mons can just keep growing, reaching this absolutely insane height of over 24 kilometers. All right, so simple rules make simple shapes. Electromagnetism makes angles, gravity makes spheres. Got it. But what about life? Look at us. We are anything but simple. How on earth do these basic laws of physics explain something so incredibly complex and, well, alive? And this is where it seems like the whole idea should just fall apart. Because there's this really, really important rule in physics, the second law of thermodynamics. And what it says, basically, is that the universe loves chaos. Disorder, the fancy word is entropy, is always going up. Left to its own devices, everything just pulls apart. So, you see the problem, right? It's a massive paradox. If the fundamental tendency of the universe is towards messiness and decay, how in the world can you get something as beautifully and intricately organized as a living cell? It seems to go against the most basic rule of everything. Okay, get ready for this because this is the big twist. Life doesn't actually break that law. At all. In fact, life exists because of that law. It's a direct product of the universe's slide into chaos. I know that sounds backwards, but life isn't the exception to the rule. It's the rule finding its most creative, most amazing expression. So how does that work? Well, the trick is living things aren't closed boxes. We are absolute masters at finding a source of energy, like the incredible flow of energy from our sun, and using it to build these little pockets of order for ourselves. We build cells, we build bodies. But, and this is the crucial part, there's a price to pay. To create that little bit of order here, we have to pump out a ton of disorder back into the universe, mostly as waste heat. So think of life as this incredibly clever engine that creates local tidiness by making the rest of the universe even messier. So when you put all this together, understanding the shape of a water molecule, the pull of gravity, the flow of energy that makes life possible, it all brings us back to where we began. It gives us a completely new perspective on our world and on ourselves. You know, when you hear astronauts talk about seeing Earth from space, they always talk about how it changes them. They see this beautiful, fragile blue marble hanging in the dark. No borders, just one single living system. And they're seeing the results of everything we've just talked about. The forces that make it a sphere, that swirl its oceans, that create its atmosphere. And that's really what science does for us, isn't it? It's like gaining altitude, but with your mind. It lets you pull back from all the day-to-day noise and complexity and see the underlying connections, these simple, beautiful rules that tie a tiny snowflake to a giant star and connect both of them directly to us. And thinking about all that leaves us with one last big question for you to ponder. When you realize that your existence, is the result of this unbelievable intricate dance between physical laws and pure chance, this long chain of lucky breaks stretching back billions of years, how does that make you feel? Does it make you feel tiny and irrelevant, or does it make you feel incredibly, unbelievably valuable? For a deeper exploration of the fundamental forces shaping planets, weather, life, and the cosmos, check the link in the description for the full audio deep dive on forces of nature.